Solve the expression 6x squared minus 7x minus 3. Make x equal to 10. 6x squared minus 7x minus 3 is equal to 600 minus 70 minus 3. The next step is to find the prime or prime number n sub p. If n sub p is equal to 527, n sub p and its prime factors is equal to 17 and 31. T sub 1, the first term is equal to 6x squared, which is equal to 2x multiplied by 3x. T sub I independent term is equal to minus 3, which is equal to minus 3 times plus 1 or plus 3 times minus 1. The prime number 17, which arithmetically equals 10 plus 7, which algebraically equals x plus 7. The prime number 17 that arithmetically equals 20 minus 3, which algebraically equals 2x minus 3. The prime number 31 which arithmetically equals 30 plus 1, which algebraically equals 3x plus 1. The prime number 31 which arithmetically equals 40 minus 9, which algebraically equals 4x minus 9. Now with the terms of t sub 1, 2x and 3x. We look for the factors that satisfy t sub 1. The factors satisfying t sub 1 are 2x minus 3 and 3x plus 1. As a result of 6x squared minus 7x minus 3 is equal to 2x minus 3 multiplied by 3x plus 1. Solve the expression 20x squared plus 7x minus 6. Make x equal to 10. 20x squared plus 7x minus 6 is equal to 2000 plus 70 minus 6. The next step is to find the prime or prime number n sub p. N sub p is equal to 2064. N sub p and its prime factors is equal to 2 to 4, 3 and 43. T sub 1 first term is equal to 4x multiplied by 5x. T sub I independent term is equal to minus 6 times 1 or minus 3 times 2. Multiply 2 times 4 times 3, which is equal to 16 multiplied by 3, which is equal to 48. The number 48 which arithmetically equals 40 plus 8, which algebraically equals 4x plus 8. Or also 48 which arithmetically equals 50 minus 2, which algebraically equals 5x minus 2. The prime number 43 which arithmetically equals 40 plus 3, which algebraically equals 4x plus 3. Or also 43 which arithmetically equals 50 minus 7, which algebraically equals 5x minus 7. Now with the numbers of t sub I, we look for the factors that satisfy t sub I. The factors satisfying t sub I are 5x minus 2 and 4x plus 3. As a result of 20x squared plus 7x minus 6 is equal 5x minus 2 multiplied by 4x plus 3. Factor the expression x to the 4 minus 4x cubed minus 7x squared plus 22x plus 24. Make x equal to 10. As a result we have 10 mil minus 4 mil minus 700 plus 220 plus 24. The next step is to find the prime number, n sub p. N sub p is equal to 5544. Which in its prime factors is equal to 2 cubed, 3 squared, 7 and 11. T sub 1 equals x to 4, which is equal to 4 times x. T sub I, the independent terms of the factors, which is equal to 24, which in its prime factors is equal to 2 cubed, and 3. Their possible combinations could be 4, 2 and 3. Let us start with the possible n sub p, of degrees 1, for example, the 7 which arithmetically is equal to 10 minus 3, and algebraically is equal to x minus 3. We cancel in n sub p the 7, and of the t sub I, independent terms the 3. We continue with 11, which arithmetically is equal to 10 plus 1, and algebraically is equal to x plus 1. We cancel the 11 of n sub p. As t sub 1 is equal to 4x, that is to say that the possible factors would be 4. And we already have 2 factors. In t sub I, we lack 2 factors ending in 4 and 2. Let's start with 4. A possible factor ending in 4 is with n sub p equal to 14, which arithmetically would be equal to 10 plus 4, and algebraically would be x plus 4. But 14 and its prime factors would be equal to 2 times 7. And 7 no longer belongs to n sub p, so that factor is not possible. Another possible n sub p ending in 4 is 6, which arithmetically would be equal to 10 minus 4, and algebraically would be equal to x minus 4. 6 and its prime factors would be equal to 2 times 3. Which if they exist in n sub p. 2 and 3 in sub p, and 4 in t sub I simplify. So far we have 3 factors, 1 is missing. N sub p is equal to 4 times 3, which in turn will be equal to 12, and t sub I lacks only 2. A factor that satisfies the 2 conditions is n sub p equals 12, which arithmetically equals 10 plus 2, and algebraically equals x plus 2. Then as a result of x to the 4 minus 4x cubed minus 7x squared plus 22x plus 24, will be equal to x plus 1 multiplied by x plus 2 multiplied by x minus 3 multiplied by x minus 4.